Okay, hi everyone. Today we're really grateful to have David Powell, who is the regional director for the UK, Europe, and MENA region for Northrop Grumman Space. Northrop Grumman Space is one of the world's largest space companies, providing a range of innovative, reliable, and affordable space capabilities to address its customers' requirements. David joined Northrop Grumman in 2019 after 15 years in the aerospace and defense industry, fulfilling roles with PA Consulting, Rheinmetall, Thales, and Raytheon. Prior to working in the industry, David served for over 10 years in the British Army. So thank you, David, for joining us tonight.
Thank you very much, Tristan. I'm going to share my screen in a second, but just to say hello to everyone, thank you for the introduction. I'm really glad to be here tonight. We're going to talk about on-orbit servicing this evening. So hopefully I can give about sort of 30, 40 minutes presentation on what we're up to. And then we can get into some questions and answers and some discussion. So unless there's anything up front, I'm going to share the screen now, which hopefully will work, and then we can carry on that way. So, Tristan, Udesh, can you give me a thumbs up if you can see my screen?
Yeah, we can see it.
Brilliant. Perfect. Great. So, as I said, we're going to talk about on-orbit satellite servicing, particularly at the geostationary orbit, which is where the work we've presently been doing has been focused. And as Tristan said, my role is working for Northrop Grumman Space Systems, and I'm the regional director covering the UK, European, and Middle Eastern region. So just to give you a bit of a sort of a background on what Northrop Grumman Space does, we're one of the largest space companies in the world, and we're very much focused on end-to-end mission solutions. And I'll go into detail a little bit about all the things we do, but really we work on everything from small satellites, launch systems, on-orbit servicing, and some very sort of complex and quite innovative things. And really what we focus is on agile, affordable, innovative, and reliable systems for our customers. In terms of the size of the business, we're about 25,000 people, mainly based in the United States. And the size of the business is around $8 billion in annual revenue. And we're based out of Dulles, Virginia, so just outside Washington, D.C., about 20 minutes from the main airport. In terms of how the business is structured, we've got 5 divisions. So moving across the slide there, our strategic space systems business is headquartered in California, in a facility we call Space Park. Over 6,000 people there working on a whole range of programs. A lot of work for our national government clients in the US, but also a lot of work for NASA, our protected communications, and particularly strategic space systems have been leading on the James Webb Space Telescope for NASA. And you may have seen in the news that JWST has now been shipped and is ready for launch. I think December the 22nd is what's being aimed for at the moment. So that's hugely exciting for everybody, and we're keeping our fingers crossed for a very successful launch. Moving to the right, Tactical Space Systems is based out of Dulles in Virginia, where our headquarters is. And Tactical works on some of the smaller scale programs for our government clients, but also a lot of our work for NASA. So our resupply to the Cygnus space station comes out of Tactical Space Systems, and we've done that, I think, 14 times with our Cygnus spacecraft and our Antares rocket. And also our space logistics business sits within Tactical Space Systems. Moving to the center of the slide, payload and ground systems are based in Baltimore. And really the clue's in the title. They deliver our complex payloads and the ground systems for the other divisions. And they do a lot of our classified work for the US government and other government customers. We've then got launch and missile defense systems. This is our launch business. We've got a range of launch systems, both horizontal with our Pegasus rocket and vertical with our Minotaur and our Antares rocket systems. And within this business, we're also doing the rocket boosters for the SLS system, which is down at NASA at the moment, down at Cape Canaveral, being stacked, ready for launch next year. So a hugely exciting area, and some great videos that come out of that business of rocket motors being tested. And then our final business within Space Systems is our business that looks after the part of the nuclear enterprise for the US government. So a business that we don't really do a lot of export or international work, but sits within our space portfolio. So moving on to what we're going to really talk about tonight, or certainly tonight where I am, on-orbit servicing and space logistics. So if you think until very recently, and we're talking until really sort of last year, most spacecraft that were launched were never seen again close up. So you see them in the lab, you see them as they're built, and then once they're launched, you can see them on a screen in terms of dots and streaks, and you can communicate with them. But you can't actually see the state of that spacecraft, whether it's been impacted by anything, etc. They're also limited by the size of the launch vehicle. So we spend a lot of time designing spacecraft that will fit within the fairings of the launch vehicles that we have. Obviously, there are things like the space station where we managed to come around that and assemble things in space, but that was very much an edge case, very much a sort of a one-off. But the majority of things are limited by the size of the launch vehicle. In addition, once things have gone onto orbit, they're unable to be upgraded or maintained. Slowly, we're beginning to do some software over the air upgrades, but certainly there can't be any physical upgrade or maintenance. And finally, whatever went up into orbit was disposable, effectively, because you couldn't upgrade it or maintain it, and unsustainable in terms of a finite life, after which effectively they become space junk, hopefully in a responsible orbit, but worst case, cluttering up the orbits that we're trying to use. So what we're doing in space logistics is extending the life of spacecraft initially by adding extra propulsion. So effectively what we're doing is putting a jetpack of fuel onto a satellite that is running out of fuel, but its electronics are working absolutely fine. We're also now being able to offer inspection and maintenance of spacecraft. So inspection is the relatively easy bit in terms of getting cameras up to a spacecraft to see what the state is, what might be going wrong. Maintenance is a different thing, and we'll come on to that a little bit later, but at the moment, maintenance is very limited, but we're developing that. We're also looking to upgrade and augment spacecraft on orbit. So that might mean putting on an additional payload. It might mean plugging in effectively a USB cable to change the software. It may mean refueling or a combination of all those things. And then last but not least, the final bullet there, getting into the more routine assembly of multiple payloads into a single system. So I was talking about being limited by the launch vehicle size. So this is about multiple spacecraft going out on multiple launches, and then as a matter of course, assembling them into something larger on orbit. And the picture you can see on the right-hand side there is our Mission Extension Vehicle 1 in our facility in Dulles. So the first generation of space logistics, and we've been investing in, as Northrop Grumman, into our business called Space Logistics for a number of years now. Our Mission Extension Vehicle 1 was launched, you see, in 2019 there, and docked in last year in 2020. And that mission extension vehicle is docked to one of the Intel satellites, 901, which is it's a live comm satellite with a whole bunch of subscribers. Mission extension vehicle 2, as you can see, docked earlier this year, again with an Intel satellite. The difference between the two missions, the first mission was the first of a kind, so we performed that docking actually in the graveyard orbit of GEO, just to be super safe. We then performed the mission and then moved that satellite back into the GEO orbit to continue its service. The second mission, MEV-2, we actually docked within the GEO orbit, and that satellite was in service throughout the docking period. So there were thousands of people receiving their internet, their TV through that satellite while the two satellites were docking together, and nobody experienced any service disruptions, which was an absolutely amazing feat. So in terms of what MEV offers, and it's the two sort of sets of bullet points at the bottom of that slide, our service offerings really around station keeping, incline reduction. So when a satellite is running out of fuel, you start managing its fuel load, and you may allow the satellite to go into an inclined orbit. You may allow it to drift a little bit. MEV allows you not to do that because it gives you the extra fuel. We can also relocate satellites. So if a satellite provider wants to move from one area of the globe to another, instead of using the satellite's own fuel, we can dock, move that satellite to its new position, undock, and then move away and allow the satellite to continue its work. And also inspections. As I mentioned earlier, we haven't been able to see satellites until MEV really has got onto orbit. So when satellites are launched, if a solar panel doesn't deploy properly, or an antenna doesn't deploy properly, or worst case, a piece of debris or something hits the satellite, we can use MEV to carry out an on-orbit inspection and beam those pictures down to the engineers to actually show them what's happening. And economically, what MEV does, it's about deferring capital expenditure. So for a company that's running a comm satellite, you can buy an MEV and you don't need to buy a new satellite. So it allows you to defer that capital expenditure and really capitalize on that asset. So just going into a bit of detail of MEV, and then we'll get onto a video. As I mentioned before, MEV, you should think of MEV really as a jetpack. It's a jetpack full of fuel that comes along, docks on the back of a satellite, and stays there until it's no longer needed. So we've got design life of at least 15 years because we've got a lot of fuel on board. So we can either stay with one satellite and keep that going, or we can undock and move to another satellite. And it really is up to what the customer wants. The way we're docking with the host satellite is a mechanical interface only. So none of these satellites have been designed to be extended. And you'll see on the video the way we do it, but effectively we lock on to the engine, the liquid apogee, the nozzle of the liquid apogee engine, and we use that to clamp the two vehicles together. And we offer this, we can either sell an MEV as an asset, or we can lease it and offer it as a service. And for most of our clients, a service is what they're looking for. So in terms of how we put this together, obviously this is an extremely complex thing. I'm not very technical myself, but I've got some brilliant teams working with me. And the way we've done MEV is we've taken two sides of our business. So in terms of building satellites, we've done a lot of that. Our GeoStar 2s and GeoStar 3s. We've got in excess now of 35 satellites on orbit. So the teams are very, very practiced about how to do that and how to build a reliable, affordable satellite. And then on the right-hand side, our rendezvous proximity and operations and docking work is really built on all of our experience of resupplying the space station. So we've brought those two teams together to develop the MEV. And why that's really important is obviously there's huge complexity across this whole system. And one of the big things for us, although we can develop the technology, we also have to get it licensed and insured. So all of this sort of legacy capability and experience is really, really essential in order to get those licenses and, as I say, to get some insurance. Because people get quite twitchy when you say, we're going to take our satellite and dock it onto the back of your satellite. So, you need to have some, you need to be pretty confident that it's all going to work. So now we're going to move on to a video, and which hopefully there should be some music, and I'll just talk through a few bits on it as we go through. So this is the mission profile of a mission extension vehicle. So our mission extension vehicle, as you saw, was typically launched with another satellite. It's now deploying its solar arrays and its electric propulsion to start orbit raising up to the geo orbit. So this is quite a slow procedure. It can take up to a month to get up to its client satellite. It's now got onto geo, and you can see the client satellite there. So we start to move in very, very slowly. From an 80-meter distance is our first hold point. We then come to a closer hold point at 20 meters where we stop. And obviously all of the time all this is happening, both the client satellite and our MEV is communicating back to the ground. So MEV is now moving closer. So we're now holding at the 1 meter point. And this is where you can see the mechanical interface. So effectively, that's an arm we put in, and we then pull the two satellites together and clamp them as a single unit. And you can now see the two satellites operating as a stack with the solar panels at 90 degrees to each other, so they don't shadow each other. And effectively what we've got now is one spacecraft. So hopefully that sort of gave a little bit more explanation to the words I've been talking about what an MEV is. So in summary with Mission Extension Vehicle, this is the first and the second spacecraft of its kind. So lots of people have been talking about space logistics for many years, but until the last 2 years, it hasn't actually been done. But now Northrop Grumman Space Logistics have actually done that. And what you can see there on the right there is actually a picture taken by Mission Extension Vehicle of one of the Intelsat satellites. And that was one of the first pictures of a satellite in geo orbit to exist. And interestingly, if you sort of zoom in on that, there are some small holes in the blanket where micrometeorites have hit the satellite. And until we saw that, we really didn't know, would the satellite look like it did when it was launched? Would it look like the CAD models? So that really sort of showed us, the satellite we were going to dock with. So we're now going to move on from generation 1 to our second generation of space logistics. So although Mission Extension Vehicle is absolutely superb, it's quite a complex satellite to be sitting on the back of a client satellite for a long period of time. So what we're doing with our second generation is combining two systems, our Mission Extension pods, which are the size of a small refrigerator, and they offer effectively a mini jetpack, a 6-year life extension to a satellite that's in geo orbit. Very similar docking mechanism to MEV, and self-contained in terms of its power and its telemetry and command systems. And these mission extension pods are installed by our mission robotic vehicle. The mission robotic vehicle is effectively a mission extension vehicle that has got a robotic arm attached to the front of it. So our mission robotic vehicle can carry a number of MEPs. And what this means is instead of that sort of matching of one mission extension vehicle to one host, we can have obviously many hosts now, and the MRV can service them all. So the way we're going to work with this, the mission extension pods can either launch with the mission robotic vehicle. We're launching the first MRV in 2024, 2025. Or we can launch MEPs separately. And the concept is we will have a number of mission robotic vehicles on orbit, providing mission extension pods, providing maintenance, providing inspections. So effectively, we're going to have robots on orbit, which is hugely exciting. And the way we've got to this, as I said at the bottom there, this is very much, it's built on the heritage of MEV. So the way we approach things is we go step by step, prove a system, prove it all works, move to the next step, and then, yeah, this is going to be the next step on that journey. So I think we've now got another video which really sort of brings that to life a little bit. If I come back to there. So this is our mission extension pods and our mission robotic vehicle. So on this launch, we've got MEPs and the MRV. We've got 6 MEPs, which will move off by themselves. So just like MEV, they're deploying electric propulsion to do orbit raising. And we're using EP here because it's far more efficient for a long-term build, a long-term burn. And the time isn't really an essence of the essence. So now we've got the MEPs and the MRVs on orbit. The MEP brings itself close to the client vehicle, but not too close, and it waits, it loiters until the MRV comes along. You can see the robotic arm there now. So the MRV has picked up the MEP. And now we move into the rendezvous, into the client vehicle. So very similar to what you've seen with mission extension vehicles. So we're using a number of sensors there, including a LiDAR sensor and optical, in order to bring the MEP in. And again, a very similar docking procedure, but utilizing the robotic arm to put the MEP into place. Then the MRV can move off and can start actually inspecting the satellite, and then it moves away to get to the other MEPs. So the big advantage here for our customers is that MEPs are slightly simpler spacecraft, so they come in at a lower price than a mission extension vehicle, which obviously provides a lower cost solution, not as long in terms of service life extension, 6 years versus potentially up to 16 years. But it's a balance between the electronics on the payload degrading and the amount of life extension. So the 6-year point we picked out as being pretty optimum in terms of the life cycle of a satellite. So that's the sort of the first couple of generations. As I say, generation 1 is on orbit. Generation 2 is going to be on orbit by midway through this decade. And we've already got many customers to the point of very, very interested in mission extension pods for their GEO satellites. Our next steps in terms of space logistics, and these are things we're working on now, the robotics and life extension is where we are at the moment, and really taking that to the next step. So being able to do simple repairs on orbit. So that might mean deploying solar arrays, deploying antennas, doing more with that robotic arm. And also using that robotic arm to capture non-standard satellites. So I mentioned at the moment we dock onto the liquid apogee engine nozzle. That's good for about 85% of the world's GEO satellites. But for that remaining 15%, at the moment we can't do life extension with a mission extension vehicle. Once we've got MRV there, we can then do that, because we can then capture a non-standard satellite and affix an MEP to it. We're also looking at how we can start repairing proper repair on orbit and assembly. And I talked about bringing together multiple payloads into larger structures. And this might be for all sorts of reasons, but particularly around things like, we're talking about solar power on orbit now, all sorts of things like that, where we're really going to need that assembly capability. And also potentially the space debris mission as well. Space debris is an absolute hot topic. We've seen the recent anti-satellite test in the last couple of weeks, which has generated huge amounts more debris. That was at LEO, we're talking GEO here, but our systems can be used in either orbit. And there's still a huge amount of debris in the GEO orbit. So we can certainly work for that mission as well. And then another part of our mission and working with other parts of our business, we're doing a lot at the moment with NASA about the return to the moon, the lunar program Artemis. So these systems can be used to move cargo from Earth orbit to the lunar orbit. And as we start picking up things from the moon, potentially mining, whatever else we're going to do on the moon, bringing things back from lunar orbit to Earth orbit to then either process them on orbit around the Earth or potentially to bring them back to Earth. And then further afield, the technology we're developing, as I say, we use a step-by-step process for further space exploration. So, at that point, we're looking way out into the future. But these are sort of the steps which we are moving towards quite a rapid rate at the moment. So space logistics for us is a hugely exciting part of the business. It's got some of our best people working on it, and it's really sort of, it's got us a lot of attention in the press over the last couple of years, to really show that this sort of thing is not just something that is talked about. It really is here now. So I've sort of got through that in just under half an hour, which is great. I must say the videos, the two videos I've shown are on our YouTube channel. So if you go to Northrop Grumman and within the Northrop Grumman Space part of the business, you can see the videos on space logistics. And there's actually another video in there which I was going to show, but I didn't think I might have time and wanted to leave a lot of time for discussion, which is actually the two our MEV-2 docking onto the Intelsat satellite. And it's a video that's been developed from a whole bunch of still frames and really shows those two satellites coming together on GEO orbit. So it's really a first in the world. So with that, I'll hand over to Tristan and Yadesh, and hopefully we can have some good questions and discussion. I'll stop sharing the screen.
Thanks for the presentation. It was really lovely, and it has lots of information. It was really interesting. So I had a question myself, and it was about space debris. And I was just wondering, to what extent would you consider that in-orbit servicing reduces the number of space debris in space?
Yeah, absolutely. And that's one of the huge benefits of on-orbit servicing. Yeah, at the moment we're at the very early stages of it, but as we were talking about, satellites, once they go up there at the moment, once they run out of fuel, they effectively become space debris. What we can do with this is we can extend the life of those satellites, which means you don't need to launch a new satellite. We can change the payload, we can augment the payload, which really potentially reduces the number of satellites we need to launch. We can refuel, so refueling interfaces are being developed at the moment. And worst case, when things do come to the end of the life, which inevitably they will, if they can't deorbit themselves, we can either move those items to burn up, or we can move them out to a safe orbit. So it really does help the whole sort of sustainability piece.
So there's a lot of questions in the chat, and I'm trying to run through them real quick. So one of the questions was about your main competitors and how the satellites in your company basically what do the satellites in your company bring that your competitors do not? Like Maxar Technology, I think, is one of the companies that they were asking about.
Sure. So yeah, I mean, the space market is like any other, as you all know. There's a number of competitors, and there's space in the market for us all. We bring a range of satellites from, I guess we don't really do nano satellites, but from small satellites to very complex spacecraft. I guess some of our unique features, we tend to focus on very reliable satellites that are also affordable. So we target specific missions, just like other competitors, or lots of times they're partners actually. Some parts of the market will want to target maybe a very low cost satellite that is only going to last for a number of years in order to provide a capability demonstrator. But other customers, particularly some of the government customers and big commercial telecoms providers, they want very high reliability satellites with a lot of capability that will last for an extended period. So it's a little bit sort of horses for courses. You can, whatever you want in a satellite market, there's somebody out there that can provide it for you. And we work with many companies across the space industry, as do many of our other partner companies. If I could think about the on-orbit servicing and our competitors there, there's a number of companies that are working on on-orbit servicing now. So companies like Astroscale and ClearSpace and D-Orbit. And to be honest, just like we were talking about satellites, then there's space in this market for us all. On-orbit servicing and manufacturing, assembly, removal of debris. There's a huge amount to be done up in space. At the moment, as I say, we've focused on the GEO market. That's because we could see a commercial business case for working in GEO. When we started doing that, the LEO orbit, the LEO sort of economy hadn't really developed that much. It really has now. So there's a lot of different opportunities across the market there. There's also companies out there like Orbit Fab who are developing the first fuel stations on orbit, which is that's another really interesting area.
So thanks for your answers. Really good to hear from what you have to say about it. I was also wondering if there's any country who has like any sort of concern of using your technology to try to hack or go on other satellites or they're not supposed to go on to.
Yeah, it's a really good question, and it certainly is one of those things that spacecraft with this capability fall into something called dual use. It can be used absolutely for what it's intended for, but you could use it if you wish to do something nasty to somebody else's spacecraft. Realistically, it's clearly not something we would do. There's so much space situational awareness out there. We all know across the world, and we share data about what's going on in space. But it is very possible. The whole sort of docking of two satellites together is a hugely exciting technology. I guess you could say that any satellite could be used to do something nasty to another satellite as long as it had fuel on. But particularly, yeah, absolutely, it's a concern with this sort of satellite that it's actually designed to go near other satellites and potentially, do something to them. But it's certainly not what it's designed for, Tristan. But a good question.
Thanks for the reply. So there were a lot of questions pertaining to how the satellites would be able to cater. Basically, how would you be able to cater for a range of different satellites of different sizes? I guess is what most of the questions here are actually asking. Like some of them are asking, how do you cater to like a smaller size satellite, which I remember you were referring to in your presentation. But I think if you could share a bit more about that, it would be quite helpful.
Yeah, absolutely. And there will need to be, yeah, absolutely. So there are, obviously all sizes of satellite up there on orbit at the moment. So we've focused pretty much at the moment at sort of large, quite complex satellites that are on geo orbit, and they've got an extended lifetime, which allows us, and that's what we've designed our technology to do. So that's the focus at the moment. Could we extend smaller satellites? Absolutely. We would need to change some of the hardware. But then it comes down to the discussion on the business case of which satellites do you extend, and if you've got take a small a CubeSat, is it economically viable to extend that, and can you actually put the systems on it that can allow it to be extended? And there's probably a sort of a sweet spot in sort of the mid-sized to the larger satellites, where you start the life extension work. The reason as I said, the reason we focus where we are at the moment is we could see, when we were talking to our customers that had telecom satellites there, who their payloads are absolutely working fine. As we all know, electronics now, as long as you look after electronics, even if it's up in space, they can last a huge amount of time. But particularly with chemical fueled satellites, there's only so much fuel you can take up there. So that's how we develop this use case. But absolutely, yeah, if there's a business case to do smaller satellites, and certainly, that's where some of the other companies on the market, Astroscale are focusing at the moment on the LEO orbit, with it's a similar system in terms of functionality, but obviously different in size and scale.
Yeah, thanks for the answer. We got a question from the chat from Alexandra. She was asking if a tech for life expansion is compatible with any satellite platform, and when it should be done, like how long before the end of life of a GEO satellite? Sure.
So the technology at the moment, so we estimate that we're compatible with about 85% of current GEO satellites. That's because those satellites all have a liquid apogee engine, which they've used to get to geo orbit, and then the engine is completely redundant at this point. They've got to where they need to be, which allows us. That's what our engineering team identified as effectively a grappling point that was on the highest percentage population of the GEO satellites. So the other 15%, as I mentioned, at the moment we can't give them on-orbit servicing. With mission robotic vehicle with a robotic arm will allow us to do that because we'll be able to grapple with them. Moving on to the second point of when to do this, and again, this is another debatable area. So when you've got a satellite there with an amount of fuel on it, you can run that to a period where you've only got enough fuel to move out to graveyard, and you could have put mission extension vehicle on at that point, or actually you could put the mission extension vehicle sort of midway through its life, to allow you to keep that fuel on the primary satellite. For future service. So it all really depends on what our customers want. It can happen as early or as late in the life. I mentioned relocation, which is one of the use cases for extension. So to move a satellite from one place in GEO to another would use a significant amount of onboard fuel. So if a client wanted to do that, you might put a mission extension vehicle onto that client satellite very early in its life cycle, move it to a new position using the MEV fuel, and then undock and allow the client satellite to continue to use its fuel. So I hope that answers that question.
So another one of the questions in the chat is regarding military use of these satellites. So could you share a bit about that?
So mission extension vehicle and space logistics is not something we're designing for military use at all. Clearly, you could come up with use cases where these could be used in a military sense, but that's not it's not something that we're focusing on for space logistics at all. I think some of the very interesting use cases around life extension of government satellites. So we can see certainly for the UK government, we've got military satellite communication satellites, which the Skynet series of satellites, which have been on orbit for we're at the Skynet 5 constellation at the moment, and certainly those satellites, they're military satellites, and we could provide life extension to those. And similarly, other countries have Earth observation satellites at GEO, and certainly MEV could be used to extend effectively any satellite that is on orbit. So in terms of those use cases, we can certainly provide extension of life to allied satellites, but it's certainly not a system we're developing for military use in an offensive way.
Okay, thanks for that. I was wondering too, what's the plan of Northrop Grumman for starting in space manufacturing? Like, where are they at right now?
Yeah, it's a hugely exciting area in space manufacture. So you may have seen in the press recently, we've invested in a company called Orbit Fab, who I mentioned they're doing fuel stations, which is sort of linking to orbit manufacture. But we're looking at all sorts of different options, particularly around what happens after the International Space Station. So there's a commercial space station program that NASA is running at the moment. And certainly as we start to develop more missions towards the moon, I think in-space manufacture at that point is going to become really essential. So there's and I guess that part of it is more assembly. The manufacture in terms of actually carrying out procedures to put together new compounds, new pharmaceutical compounds, new semiconductor compounds, etc., on orbit. There's lots of companies talking about that at the moment, and certainly we're in discussions with a bunch of people across the space ecosystem to develop that. I think it's an area over the next sort of couple of decades we're going to see far more of.
So that is very interesting. So there is another question. So they would like to know what is the role of Northrop Grumman in the Artemis mission and the Lunar Gateway, and especially the HALO, the Habitation and Logistics Outpost, and the Lunar Transfer Element?
Sure, great question. So yeah, within Artemis, so HALO, as you said, is the habitation and logistics module, which is going to orbit the moon. So at the moment, we're building HALO. We're the prime contractor for HALO for NASA. The HALO spacecraft itself is based on our Cygnus spacecraft that we've used to resupply the International Space Station. So again, similar to MEV, building on tried and tested technology and taking it to the next step forwards. In terms of the human lander, we've also been awarded a contract from NASA to develop one of the human lander systems. There's a number of contracts being awarded. So that's in development at the moment, or in delivery at the moment. And there's also, there's a whole bunch of stuff around the moon, particularly around the lunar rover program. So what are the astronauts going to use to move around on the moon? And that's we'll all remember the pictures of the Apollo lunar buggies, which were, I guess, potentially are very, very complex at the time, but slightly rudimentary compared to what we might have for this next mission. So for Artemis, we're involved in that as well. And if we go back to the heritage, Northrop actually we were the manufacturer for the lunar descent module for the Apollo mission. So yeah, we're really pleased to be involved in the lunar program, and I think it's an area that it actually brings the space community across the whole world together, which is very exciting.
So thank you for your answer. I was wondering what will happen to your satellites once they because of course we have lots of space debris. You're never too sure if one of them hits your satellite. So what happens when one of the space debris, for example, would hit your aircraft and break it?
Yeah, so I guess if we sort of start in the geo orbit, so the geostationary orbit clearly is absolutely essential to the services we get from space for Earth. So that needs to be absolutely protected. So good stewardship, when a geosatellite is reaching the end of its life, you take it out to what's called the graveyard orbit, which is further out into space, effectively an orbit which I guess is less useful to us. It sounds awful, but it's a less useful orbit, and the spacecraft effectively then becomes debris. It's an unfortunate case of that's where we are with space technology. If we come to the closer orbit, so a LEO orbit, you've got the benefit there of potentially bringing the satellite closer to the Earth and burning it up in the atmosphere. Of course, that also potentially has a number of hazards depending on how you do it. And we've seen in the press that certainly over the last couple of years, some unmanaged re-entries where things haven't fully burnt up. And equally, we didn't know exactly where things were going to land. So again, not an ideal situation. But I think the future for this is, as we were talking about a little bit earlier, we're developing sustainable, as much as we can, systems. So for LEO, systems that can be deorbited in a managed way. So we know that they're going to burn up, and if they're not going to burn up fully, we can make sure that those items that come through the atmosphere land in a safe space. And certainly on GEO, it's about not having failures on orbit, or when you have got a failure on orbit, being able to grapple that piece of what has now become debris and move it off into an area which is safer to allow us to keep getting those services from space. Udesh is frantically skimming the chat. I can't see the chat, so I can't help you.
Yeah, so actually your answers answer a lot of the questions here. So when I'm reading this, I'm actually trying to scan and not ask you a question that you actually haven't already answered, which is quite difficult given that you're doing a great job. So there's a question here regarding smaller CubeSats, which I believe you sort of mentioned in a previous answer. So they were asking, do you think there will be any solutions for smaller CubeSats as they are rising in number? Will there be an issue with the technology to remove them from orbit, or any plans to prolong their lifetime?
Yeah, so with CubeSats, there's a huge amount of smaller satellites going into orbit. And absolutely, we can. I think the key things with small satellites is to make sure we can do the managed re-entry, as we talked about. And there are a number of companies that are putting standards onto the market for interfaces, so that those satellites can be, if necessary, attached to and brought down in order to burn up into the atmosphere. Could they be extended? Yes, absolutely. At the moment, we've developed refueling adapters for GEO orbits, which obviously, they're quite, I guess, They can be relatively large because they're on larger spacecraft. A nano satellite, a small CubeSat, needs something that's much smaller. Those could absolutely be developed. It's scaling down of the technology, and we could start seeing refueling of those satellites. It comes back to what I sort of mentioned a little bit before, the sort of the business case of sometimes you put a small satellite together at the lowest possible cost you can in order to get a capability onto orbit to demonstrate it. Other times you put a small satellite together with high reliability components and a lot more redundancy because you want that capability to endure. So those satellites do tend to be more expensive, and therefore the economic business case for extension really does stack up. So we're not quite there yet, but within the next few years, as LEO is really growing, it certainly is very, very possible.
So there was a follow-up question, but I think you just sort of answered in the end. Like someone was wondering whether it would be economically sustainable to actually remove them from the Earth orbit after they've done their job and once they sort of died.
Yeah, so if I just sort of build on that one a little bit. So the whole space debris is a problem that we clearly we can all see. There is a massive problem with debris, which unfortunately is getting worse. We need to figure out a way really across the world of what are we going to do with that, and are we going to manage the debris that's there? So effectively, just make sure we don't make the problem any worse, and that could be through when you're launching a new satellite, you need to make sure that satellite can be removed from orbit, or even potentially when you're launching a satellite, you need to be able to pay for a service to take another piece of debris out of orbit. There's all sorts of ideas that are there. One of the challenges I think we've got as a space community at the moment is it comes back to economics. There's a lot of space debris up there, and the technology is there to remove it, but who's willing to really pay to go and do that? Again, it's one of these awful truths that somebody has to pay for a mission, and that's why, as I say, some of the ideas are coming up with. We're getting to our as you launch new things that actually there may be a surcharge there or a service fee which says as well as not adding to the debris problem, actually you're going to start helping us resolve it. But it's one of those questions which really we need to come together as all the countries on Earth to solve this. If we don't, there's I'm sure you've seen awful simulation videos on YouTube of we have one crash, and one crash turns into multiple crashes, and eventually we have orbits that we just can't use. And once we get to that state, it's going to be really difficult to come back. So it is a really clear and present problem that we need to resolve as a space community.
So one of the questions someone in the chat has put up is, do you think machine learning will play a big role for an orbit servicing? And what are your opinions about machine learning?
So I'm not absolutely not the expert on ML, but we do have a lot of teams that are. And yeah, certainly machine learning, on-orbit processing are really beginning to start coming into the spacecraft that we're designing and beginning to launch now. Certainly for the future, yeah, absolutely. I mean, particularly when you look at mission extension vehicle, what we've been doing at GEO, you've got to have some clever systems here. You can't remote control them from the ground. So systems that learn, systems that can adapt themselves, can react to things that are happening around them. Are certainly, that's what we want to strive towards. With ML coming on in leaps and bounds, as I say, those are the satellites which are being developed at the moment to have those sort of capabilities. It also sort of comes to the sustainable point of when we can start developing satellites which we can potentially change the software, upgrade the software, start to develop on orbit. We can see satellites that actually may launch with a level of capability, and actually we can improve their capability while they're on orbit. from the software side, through them from learning themselves and working with them, and on the hardware side, potentially augmenting payloads with our robotic fleet, so we can really start seeing satellites that can grow.
So I had a more general question about like the industries, especially about about in the UK, like how many people working for Northrop Grumman in the UK, and like what's like their sort of area of expertise?
Yeah, absolutely. So Northrop Grumman in the UK, we're about 900 people at the moment. And the business is split into a number of sort of subsystem areas. So we have a business that works a lot on cybersecurity, and that works very much in the sort of government sphere and with industry as well. We have a business that works developing command and control systems and does a lot of work for both for the Navy, but also for commercial customers with radar systems. We support a number of aircraft for the Royal Air Force. And then we have a bunch of other businesses that are developing all sorts of software solutions. So that's in the UK. And then broadly, across Europe, we also have businesses in Germany and in Italy, both developing electronic systems, predominantly for aircraft, and also a business in France. So although we're a US headquartered company, we do have businesses across the world.
So there was another question in the chat. This is also sort of a general question. They were wondering, well, how much does it cost to operate a satellite or one of the satellites like the MEV and the MEP?
So a great question. Cost to operate is an interesting one. So in terms of where we've space logistics, so space logistics is a complete Northrop Grumman developed business and capability. So we've over the last few years we've invested tens, if not hundreds of millions of dollars into this, because we could see that there was a commercial market there. So through that we've developed our manufacturing center, our simulation center to put this together, and we fly the satellites from our headquarters in Dulles. So putting a sort of a figure on how much it costs to operate is pretty difficult. In terms of the costs for the MEV and the MEP, we've designed them to really be affordable. So there's no point designing an in-orbit servicing system which costs far more than the satellite you're going to operate, to service. So that's been a big thing for us, how to design them to a cost which makes sense for a customer. But as to actually putting the actual figures on it, I'm afraid I can't answer that one.
So I think we're just gonna have one last question, which is again like very general, and it's just sort of like for students to see what they need to do. So it's just, could you give any general advice for students or young professionals who would like to work in this sector in the future?
Yeah, absolutely. I think the space industry is booming across the world at the moment, and it's an industry which is growing very quickly. Certainly in the UK, we've got the National Space Strategy has been launched, which is really showing the government's support to the space industry. So we're beginning to see a lot more jobs being advertised. I'm seeing jobs for both Northrop Grumman and a bunch of the industry partners we work with being advertised on a daily basis. And I think the real thing with space is to remember that space, there are some super technical engineering and software jobs, but also it's a complete industry. So my background is I am not a space engineer. I am not into space technology in any shape or form, but absolutely I can work in the space industry. Likewise, we need human resources professionals, we need accountants, we need project managers. So I think the message is really there's a spot for everybody in the space industry. And certainly what I've found since I've joined the space sector over the last few years is there's a huge amount of excitement. Everybody is very, very positive. There are some great diverse teams that are really delivering things very, very quickly. So if you want to be in a really interesting industry, I would certainly recommend space to anybody.
Thanks. I think that's going to be the end. So yeah, thanks a lot for coming here. I think we had a really interesting discussion. So yeah, thanks for your time.
Thank you very much. And hopefully we can meet